So for this problem, again, I'm going to have you read through the problem for a moment. We're going to go through this one a little bit faster than we have the last two. So again, we are looking for our variables, and I want to find the phrase that's going to tell me what my variables are. And so as I'm reading through here, I want to find the speed of the Cylon radar in still space and the speed of the cosmic wind. So as I go to write my variables, again, use full phrases. We're going to let maybe red be the speed of the Cylon radar in still space. We could call that C for Cylon radar. Don't forget the units. In this case, the units are going to be parsecs per hour, PC per hour. And then let's do maybe blue for the speed of the cosmic wind. I didn't think about that one very well, did I? I'm going to change the variable letter that I used for my Cylon radar. I actually am going to want to change that because I want variables that are very descriptive. So for us, I'm going to let R be the speed of the Cylon radar. And then W will be the speed of the cosmic wind. This way I don't get confused by my C, wondering which one that belongs to. So this will be the speed of the cosmic wind. And this is also in parsecs per hour. So once we have our variables, we want to come up with our equations. We are still going to use the relationship D equals R times T. And I'm still probably going to want to have a there equation and a back equation, because that's typically what we do. We normally just go there and then back again. So, what distance do we have? Our distance is always 4. So that's going to be the d part of both of these. 4 equals something here, and 4 equals something else over here. Now, I have a constant cosmic wind from Caprica to Delphi. So if I look at the times that I'm going to be going, I can see that on the way there, I was with the wind, and on the way back, I was against the wind. That will help us, again, come up with what my rate is going to be for both of them. So, on the way there, it took me 2 hours. On the way back, it took me 2.5 hours. So that must mean that there, I was going R plus W, and back I was going R minus W. It's kind of a nice little shortcut to help you figure out which way your rate needs to go. So we're ready to start solving. Again, I'm going to do like I did on the previous slide. I'm going to distribute. So I've got 2R plus 2W equals 4. And then 2.5R minus 2.5W also equals 4. And now I have to make a judgment call. Which method would I like to use to solve this? You are free to choose whatever you would like to choose, but I like to choose things that just don't leave much room for error. So in this case, I'm actually going to substitute. I'm going to isolate, let's isolate W in my their equation. And I can see that it will leave me with fewer fractions. Leaves us with fewer fractions or even decimals. I don't like either when I'm solving these types of problems. So 2r plus 2w equals 4. 2w equals 4 minus 2r. So w equals 2 minus r. I saw that all of these pieces, all of these coefficients were divisible by 2, which is why I figured that doing my substitution was going to be the easiest route. So now I'm going to pick, oop, that's not what I wanted. My pen isn't oriented very nicely. So now I'm going to pick up this chunk and plug it into my other equation. So it's going to go right there. So in a different color, 2.5 r minus 2.5 times 2 minus r should give us 4. And now I'm just going to solve and hope I do so carefully. 2.5r minus, okay, 2.5 times 2 is 5, and then plus 2.5r equals 4. What I wind up with, 2.5 and 2.5 is 5. So 5r, I add 5 to both sides. 5r equals 9. R equals 9 over 5. If you get out your calculator, you will notice that that should be 1.8. So we have r. R equals 1.8. Now we need to find w. So I can't, unfortunately, use my nice little solved equation. That's not allowed. But I can come up here and use this equation to solve for w. And that's easier of the two equations to work with. So we'll go with green. To solve for w, I'm going to use 2r plus 2w equals 4. 2 times 1.8 is 3.6 plus 2w equals 4. Subtract 3.6 from both sides. 2w equals 0.4. Divide both sides by 2. You're going to wind up with w equals 0. And make this cooperate. 0.2. That should be my w. So let's check in a different color than we've used. I will use my 2.5 equation to check because I just used my 2 equation to solve for w. 2.5 times 1.8 minus 2.5 times 0.2 should equal 4. Now, I can do a lot of checking in my head. This is not some of it. So what I'm going to do is I'm going to pull up the calculator, and I am going to calculate this and put the calculate screen here on the computer. So bear with me for a moment. And once I grab my calculator screen, which is here, I can tell that my check worked out. 2.5 times 1.8 minus 2.5 times 0.2 does in fact equal 4. Works out. Our last step is our sentence. The rater is going 1.8 parsecs per hour, while the wind is blowing at 0.2 parsecs per hour. And I think I was a bad student, and I didn't put a sentence at the end of my last slide. Let's go check. I didn't. Look at me. I'm such a bad student. I'm going to write that sentence in really quick. The falcon travels at 15 light years per hour, and the wormhole current, well, that's not very clear. The wormhole goes 3 light years per hour. See, don't follow your teacher. She did a bad thing. Alright, go back. So again, let me check in on time. Let's see how we're doing here. We might have time for a new type of problem. I can't find my recorder. There he is. We're at 11 minutes. I think we're good. I think I will let us start this problem on the next video.